In this lesson, you will learn about using authentication on the firewall policies of a FortiGate. In this lesson, you will explore the following topics: methods of firewall authentication, remote authentication servers, user groups, using firewall policies for authentication, authenticating through captive portal, monitoring and troubleshooting. After completing this section, you should be able to describe firewall authentication, identify the different methods of firewall authentication available on FortiGate devices, identify supported remote authentication servers, describe active and passive authentication and order of operations. By demonstrating competence in methods of firewall authentication, you will be able to describe and identify the supported methods of firewall authentication available on FortiGate. Traditional firewalling grants network access by verifying the source IP address and device. This is inadequate and can pose a security risk because the firewall cannot determine who is using the device to which it is granting access. FortiGate includes authentication of users and user groups. As a result, you can follow individuals across multiple devices. Where access is controlled by user or user group, users must authenticate by entering valid credentials, such as username and password. After FortiGate validates the user, FortiGate applies firewall policies and profiles to allow or deny access to specific network resources. FortiGate supports multiple methods of firewall authentication: local password authentication, server-based password authentication, also called remote password authentication, two-factor authentication. This is a system of authentication that is enabled on top of an existing method. It cannot be enabled without first configuring one of the other methods. It requires something you know, such as a password, and something you have, such as a token or certificate. During this lesson, you will learn about each method of firewall authentication in detail. The simplest method of authentication is local password authentication. User account information, username and password, is stored locally on the FortiGate device. This method works well for a single FortiGate installation. Local accounts are created on the user definition page, where a wizard takes you through the process. For local password authentication, select Local User as the user type and create a username and password. If desired, you can also add email and SMS information to the account, enable two-factor authentication, and add the user to a pre-configured user group. After you create the user, you can add the user, or any pre-configured user group in which the user is a member, to a firewall policy in order to authenticate. You will learn about user groups and firewall policies in this lesson. When server-based password authentication is used, a remote authentication server authenticates users. This method is desirable when multiple FortiGate devices need to authenticate the same users or user groups, or when adding a FortiGate to a network that already contains an authentication server. When you use a remote authentication server to authenticate users, FortiGate sends the user's entered credentials to the remote authentication server. The remote authentication server responds by indicating whether the credentials are valid or not. If valid, FortiGate consults its configuration to deal with the traffic. Note that it is the remote authentication server, not FortiGate, that evaluates the user credentials. When the server-based password authentication method is used, FortiGate does not store all, or in the case of some configurations, any, of the user information locally. FortiGate provides support for many remote authentication servers, including POP3, Radius, LDAP, and TACACS+. POP3 is the only server that requires an email address as the login credential. All other remote authentication servers use the username. Some POP3 servers require the full email with domain, user@example.com. Others require the suffix only, while still others accept both formats. This requirement is determined by the configuration of the server and is not a setting on FortiGate. You can configure POP3 authentication only through the CLI. Note that LDAP can be configured to validate with email rather than the username. You can configure FortiGate to use external authentication servers in the following two ways. Create user accounts on FortiGate. With this method, you must select the remote authentication server type, Radius, TACACS Plus, LDAP, point FortiGate to your pre-configured remote authentication server, and add the user to an appropriate group. This is usually done when you want to add two-factor authentication to your remote users. Remember, POP3 is only configurable through the CLI. Add the remote authentication server to user groups. With this method, you must create a user group and add the pre-configured remote server to the group. Accordingly, any user who has an account on the remote authentication server can authenticate. If you are using other types of remote server, such as an LDAP server, as the remote authentication server, you can control access to specific LDAP groups as defined on the LDAP server. Similar to local password authentication, you must then add the pre-configured user group in which the user is a member to a firewall policy in order to authenticate. We will discuss user groups and firewall policies later in this lesson. Traditional user authentication requires your username plus something you know, such as a password. The weakness with this traditional method of authentication is that if someone obtains your username, they only need your password to compromise your account. Furthermore, since people tend to use the same password across multiple accounts, some sites with more security vulnerabilities than others, accounts are vulnerable to attack, regardless of password strength. Two-factor authentication, on the other hand, requires something you know, such as a password, and something you have, such as a token or certificate. Because this method places less importance on, often vulnerable passwords, it makes compromising the account more complex for an attacker. You can use two-factor authentication on FortiGate with both user and administrator accounts. The user or user group to which the user belongs is added to a firewall policy in order to authenticate. Note that you cannot use two-factor authentication with explicit proxies. You can use one-time passwords, OTPs, as your second factor. OTPs are more secure than static passwords because the passcode changes at regular intervals and is only valid for a short amount of time. Once you use the OTP, it cannot be used again, so even if it is intercepted, it is useless. FortiGate can deliver OTPs through tokens, such as FortiToken 200, hardware token, and FortiToken Mobile, software token, as well as through email or SMS. To deliver an OTP over email or SMS, the user account must contain user contact information. FortiTokens and OTPs delivered through email and SMS are time-based. FortiTokens, for example, generate a new 6-digit password every 60 seconds by default. An NTP server is highly recommended to ensure the OTPs remain in sync. FortiToken Mobile Push allows users to simply accept the authorization request from their FortiToken mobile app without the need to enter an additional code. Tokens use a specific algorithm to generate an OTP. The algorithm consists of a seed, a unique, randomly generated number that does not change in time. The time, obtained from an accurate internal clock. Both seed and time go through an algorithm that generates an OTP or passcode on the token. The passcode has a short lifespan, usually measured in seconds, 60 seconds for a FortiToken 200, possibly more or less for other RSA key generators. Once the lifespan ends, a new passcode generates. When using two-factor authentication using a token, the user must first log in with a static password, followed by the passcode generated by the token. A validation server, FortiGate, receives the user's credentials and validates the static password first. The validation server then proceeds to validate the passcode. It does so by regenerating the same passcode using the seed and system time, which is synchronized with the one on the token, and comparing it with the one received from the user. If the static password is valid and the OTP matches, the user is successfully authenticated. Again, both the token and the validation server must use the same seed and have synchronized system clocks. As such, it is crucial that you configure the date and time properly on your FortiGate or link it to an NTP server, recommended. You can add a FortiToken 200 or FortiToken Mobile to FortiGate on the FortiTokens page. For the hard token, a serial number is used to provide FortiGate with details on the initial seed value. If you have several hard tokens to add, you can import a text file where one serial number is listed per line. For the soft token, an activation code is required. Note that each FortiGate and FortiGate VM provides 2 free FortiToken mobile activations. Any additional tokens must be purchased from Fortinet. You cannot register the same FortiToken on more than one FortiGate. If you want to use the same FortiToken for authentication on multiple FortiGate devices, you must use a central validation server such as FortiAuthenticator. In that case, FortiTokens are registered and assigned to users on FortiAuthenticator, and FortiGate uses FortiAuthenticator as its validation server. Once you have registered the FortiTokens with FortiGate, you can assign them to users to use as their second-factor authentication method. To assign a token, edit or create the user account and select Enable Two-Factor Authentication. From the token drop-down list, select the registered token you want to assign. All the authentication methods you've learned about, local password authentication, server-based authentication, and two-factor authentication, use active authentication. Active authentication means that users are prompted to manually enter their login credentials before being granted access. But not all users authenticate the same way. Some users can be granted access transparently because user information is determined without asking the user to enter their login credentials. This is known as passive authentication. Passive authentication occurs with the single sign-on method for server-based password authentication, FSSO, RSSO, and NTLM. Good job! You now understand the basics of firewall authentication. Next, you'll learn about remote authentication servers. After completing this section, you should be able to configure remote authentication servers, configure user authentication, understand the roles of LDAP and Radius. By demonstrating competence in remote authentication servers, you will be able to configure firewall authentication using remote user accounts defined on a remote authentication server. Lightweight Directory Access Protocol, LDAP, is an application protocol used for accessing and maintaining distributed directory information services. The LDAP protocol is used to maintain authentication data that may include departments, people, groups of people, passwords, email addresses, and printers. LDAP consists of a data representation scheme, a set of defined operations, and a request and response network. The LDAP protocol includes a number of operations that a client can request, such as search, compare, and add or delete an entry. Binding is the operation in which the LDAP server authenticates the user. If the user is successfully authenticated, binding allows the user access to the LDAP server based on that user's permissions. The root of the LDAP directory tree represents the organization itself and is defined as a domain component, DC. The DC is usually a DNS domain, such as example.com. Because the name contains a dot, it is written as two parts separated by a comma. DC equal example, comma, DC equal com. Additional entries known as objects can be added to the hierarchy as needed. Generally, two types of objects make up most entries, containers and leafs. Containers are objects that include other objects, similar to a folder in a file system. Example containers include country, represented as C, organizational unit, represented as OU, organization, represented as O. Leafs are objects at the end of a branch and have no subordinate objects. Example leafs include user ID, represented as UID, common name, represented as CN. This slide shows an example of a simple LDAP hierarchy. The FortiGate device, acting as an LDAP client, requesting authentication must be configured to address its request to the part of the hierarchy where user records exist, either the domain component or a specific container where the record exists. Similar to users, containers have DNs, and in this example, the DN is OU equal people, DC equal example, DC equal com. The authentication request must also specify the user account entry. This can be done by one of many options, including the common name, CN, or, on a computer network, the user ID, UID, which is the information users use to log in. Note that if the object name includes a space, such as John Smith, you must enclose the text with double quotes when testing in the CLI. For example, CN equal, quote, John space Smith, end quote. You can configure FortiGate to point to an LDAP server for server-based password authentication through the LDAP servers page. The configuration depends heavily on the server's schema and security settings. Windows Active Directory is very common. The Common Name Identifier setting is the attribute name used to find the username. Some schemas allow you to use the attribute UID. Active Directory most commonly uses SAMA account name or CN, but can use others as well. The Distinguished Name setting identifies the top of the tree where the users are located, which is generally the DC value. However, it can be a specific container or OU. You must use the correct X.500 or LDAP format. The Bind Type setting depends on the security settings of the LDAP server. The setting Regular to specify a regular bind is required if you are searching across multiple domains and require the credentials of a user that is authorized to perform LDAP queries, for example, an LDAP administrator. If you want to have a secure connection between FortiGate and the remote LDAP server, enable Secure Connection and include the LDAP server protocol, LDAP-S or Start TLS, as well as the CA certificate that verifies the server certificate. Note that the Test Connectivity button only tests whether the connection to the LDAP server is successful or not. To test whether a user's credentials can successfully authenticate, you must use the CLI. Use the Diagnose Test Auth Server command in the CLI to test whether a user's credentials can successfully authenticate. You want to ensure that authentication is successful prior to implementing it on any of your firewall policies. The response from the server reports success, failure, and group membership details. Radius is much different than LDAP because there is no directory tree structure to consider. Radius is a standard protocol that provides authentication, authorization, and accounting AAA services. When a user is authenticating, the client, FortiGate, sends an access-request packet to the Radius server. The reply from the server will be one of the following: access-accept, which means that the user credentials are OK, access-reject, which means that the credentials are wrong, access-challenge, which means that the server is requesting a secondary password ID, token, or certificate. This is typically the reply from the server when using two-factor authentication. Not all Radius clients support the Radius challenge method. You can configure FortiGate to point to a Radius server for server-based password authentication through the Radius Servers page. The primary server IP name setting is the IP address or FQDN of the Radius server. The primary server secret setting is the secret that was set up on the Radius server in order to allow remote queries from this client. Backup servers with separate secrets can be defined in case the primary server fails. Note that FortiGate must be listed on the Radius server as a client of that Radius server, or else the server will not reply to queries done by FortiGate. The authentication method setting refers to the authentication protocol that the Radius server supports. Options include CHAP, PAP, MSCHAP, and MS-CHAP2. If you select Default, the FortiGate will use PAP, MS-CHAP2, and CHAP in that order. Unlike LDAP configurations, the Test Connectivity button used here can test actual user credentials, but, like LDAP, you can also test this using the CLI. The Include in Every User Group option adds the Radius server and all users that can authenticate against it to every user group created on the FortiGate. So, this option should only be enabled in very specific scenarios. For example, when only administrators can authenticate against the Radius server and policies are ordered from least restrictive to most restrictive. Testing Radius is much the same as testing LDAP. Use the Diagnose Test Auth Server command in the CLI to test whether a user's credentials can successfully authenticate. Again, you should do this to ensure authentication is successful prior to implementing it on any of your firewall policies. Like LDAP, it reports success, failure, and group membership details, depending on the server's response. Deeper troubleshooting usually requires Radius server access. Note that Fortinet has a Vendor-Specific Attributes (VSA) dictionary to identify the Fortinet proprietary Radius attributes. This capability allows you to extend the basic functionality of Radius. You can obtain the Fortinet VSA dictionary from the Fortinet knowledge base, kb.fortinet.com. Good job! You now understand the basics of remote authentication servers. Next, you'll learn about user groups. After completing this section, you should be able to configure user groups. By demonstrating competence with user groups, you will be able to configure user groups to efficiently manage firewall policies. FortiGate allows administrators to assign users to groups. Generally, groups are used to more effectively manage individuals that have some kind of shared relationship. You might want to group employees by business area, such as finance or HR, or by employee type, such as contractors or guests. After you create user groups, you can add them to firewall policies. This allows you to control access to network resources, because policy decisions are made on the group as a whole. You can define both local and remote user groups on a FortiGate device. There are 4 user group types: Firewall, Guest, Fortinet Single Sign-On, FSSO, Radius Single Sign-On, RSSO. The firewall user groups on FortiGate do not need to match any type of group that may already exist on an external server, such as an LDAP server. The firewall user groups exist solely to make configuration of firewall policies easier. Most authentication types have the option to make decisions based on the individual user rather than just user groups. Guest user groups are different from firewall user groups because they contain exclusively temporary guest user accounts, the whole account, not just the password. Guest user groups are most commonly used in wireless networks. Guest accounts expire after a predetermined amount of time. Administrators can manually create guest accounts or create many guest accounts at once using randomly generated user IDs and passwords. This reduces administrator workload for large events. Once created, you can add accounts to the guest user group and associate the group to a firewall policy. You can create guest management administrators that only have access to create and manage guest user accounts. You can configure user groups on the User Group page. You must specify the user group type and add users to the group. Depending on the group you create, different configurations are required. For the firewall user group, for example, members can consist of local users, PKI peer users, and users from one or more remote authentication servers. If your remote authentication server is an LDAP server, you can select specific LDAP groups to add to your user group, as defined on the LDAP server. Note that you can also select radius groups, but this requires additional configuration on your radius server and FortiGate. See knowledgebase kb.fortinet.com. User groups simplify your configuration if you want to treat specific users in the same way. For example, if you want to provide the entire training department with access to the same network resources. If you want to treat all users differently, you need to add all users to firewall policies separately. Good job! You now understand the basics of user groups. Next, you'll learn about using firewall policies for authentication. After completing this section, you should be able to configure firewall policies. By demonstrating competence with firewall policies, you will be able to configure firewall policies to enforce authentication on specific users and user groups. A firewall policy consists of access and inspection rules, compartmentalized sets of instructions that tell FortiGate how to handle traffic on the interface whose traffic they filter. After the user makes an initial connection attempt, FortiGate checks the firewall policies to determine whether to accept or deny the communication session. However, a firewall policy also includes a number of other instructions, such as those dealing with authentication. You can use the source of a firewall policy for this purpose. The source of a firewall policy must include the source address, IP address, but you can also include the user, user group, and device type. In this way, any user, user group, or device that is included in the source definition for the firewall policy can successfully authenticate. User and user group objects can consist of local firewall accounts, external server accounts, PKI users, and FSSO users. A firewall policy also checks the service in order to transport the named protocols or group of protocols. No service, with the exception of DNS, is allowed through the firewall policy prior to successful user authentication. DNS is usually used by HTTP so that people can use domain names for websites instead of their IP address. DNS is allowed because it is a base protocol and will most likely be required to initially see proper authentication protocol traffic. Hostname resolution is almost always a requirement for any protocol. However, the DNS service must still be defined in the policy as allowed in order for it to pass. In the example shown on this slide, policy sequence 1, full_access, allows users to use external DNS servers in order to resolve hostnames prior to successful authentication. DNS is also allowed if authentication is unsuccessful, because users need to be able to try to authenticate again. Any service that includes DNS would function the same way, like the default all service. HTTP service is TCP port 80 and does not include DNS, UDP port 53. As well as the DNS service, the firewall policy must specify the allowed protocols, such as HTTP, HTTPS, FTP, and Telnet. If the firewall policy that has authentication enabled does not allow at least one of the supported protocols used for obtaining user credentials, the user will not be able to authenticate. Protocols are required for all authentication methods that use active authentication, local password authentication, server-based password authentication, and two-factor authentication. Active authentication prompts the user for user credentials based on the following: the protocol of the traffic, the firewall policy. Passive authentication, on the other hand, determines the user identity behind the scenes and does not require any specific services to be allowed within the policy. In the example shown on this slide, assuming active authentication is used, any initial traffic from local_subnet will not match policy sequence 1, full_access. Policy sequence 1 looks for both IP and user group information, local_subnet and HR group respectively. And since the user has not yet authenticated, The user group aspect of the traffic does not match. Since the policy match is not complete, FortiGate continues its search down the sequence list to see if there is a complete match. Next, FortiGate evaluates policy sequence 2 to see if the traffic matches. It matches all criteria, so traffic is allowed with no need to authenticate. When only active authentication is used, if all possible policies that could match the source IP have authentication enabled, then the user will receive a login prompt, assuming they use an acceptable login protocol. In other words, if policy sequence 2 also had authentication enabled, the users would receive login prompts. If passive authentication is used and it can successfully obtain user details, then traffic from local_subnet with users that belong to HR group will apply to policy sequence 1, even though policy sequence 2 does not have authentication enabled. If you are using both active and passive authentication, and a user's credentials can be determined through passive authentication, the user will never receive a login prompt, regardless of the order of any firewall policies. This is because there is no need for FortiGate to prompt the user for login credentials when it can determine who the user is passively. When active and passive authentication methods are combined, active authentication is intended to be used as a backup, to be used only when passive authentication fails. Good job! You now understand how to use firewall policies for authentication. Next, you'll learn about authenticating through Captive Portal. After completing this section, you should be able to configure Captive Portal and disclaimers. By demonstrating competence in Captive Portal, you will be able to configure authentication through a Captive Portal. If you want all users connecting to the network to be prompted for their login credentials, active authentication, you can enable Captive Portal. Captive Portal is a convenient way to authenticate web users on wired or Wi-Fi networks through an HTML form that requests a username and password. You can host a Captive Portal on a FortiGate device or an external authentication server, such as a FortiAuthenticator. Captive Portal for both wired and Wi-Fi networks is enabled at the interface level, regardless of the firewall policy that allows it or the port that it ultimately leaves by. Authentication being enabled or disabled on the policy is not a factor. This is true for any network interface, including Wi-Fi and VLAN interfaces. On the local network, the Captive Portal setting must be enabled on the incoming port. You can configure Captive Portal from the Interfaces page. Select the required interface. On the Admission Control page, from the Security Mode drop-down menu, select Captive Portal. Note that if you are configuring Captive Portal for a Wi-Fi network, the Wi-Fi SSID must first exist. Captive Portals are not compatible with interfaces in DHCP mode. On the Admission Control page, you also restrict Captive Portal user access. Select Restrict to Groups to control the access from the Captive Portal configuration. Select Allow All to control the access in the firewall policy configuration. You can also configure a firewall policy to suppress Captive Portal for specific devices, addresses, or services. This is useful for devices that are unable to actively authenticate, such as printers and fax machines, but still need to be allowed by the firewall policy. When suppressed, traffic that matches the source or destination is not presented with the Captive Portal login page. There are two ways you can bypass Captive Portal: through a security exemption list in the GUI under Network Interface, or the CLI under Config, User, Security-Exempt-List. Through the firewall policy. In the CLI, edit the policy and Set Captive-Portal-Exempt Enable. All traffic matching this policy is now exempt from having to authenticate through Captive Portal. Through the CLI command Config Firewall Policy, You can enable a Terms of Service disclaimer to be used in combination with captive portal authentication if desired. A disclaimer is a statement of the legal responsibilities of the user and the host organization that the user must agree to before proceeding. With this configuration, disclaimer plus authentication, the portal presents the disclaimer page immediately after successful authentication. The user must accept the terms outlined in the disclaimer in order to proceed to the URL requested. Neither a security exemption list nor a captive portal exemption on a firewall can bypass a disclaimer. FortiGate allows you to customize portal messages, which include the login page and disclaimer page. You can customize the messages on the replacement messages page. The disclaimer page is in HTML, so you must have knowledge of HTML in order to customize the message. The default layout is Simple View, which hides most of the replacement messages. Use Extended View to show all editable replacement messages. An authentication timeout is useful for security purposes. It minimizes the risk of someone using the IP of the legitimate authenticated user. It also ensures users do not authenticate and then stay in memory indefinitely. If users stayed in memory forever, it would eventually lead to memory exhaustion. There are three options for timeout behavior. Idle looks at the packets from the host's IP. If there are no packets generated by the host device in the configured time frame, then the user is logged out. Hard. Time is an absolute value. Regardless of the user's behavior, the timer starts as soon as the user authenticates and expires after the configured value. New session. Even if traffic is being generated on existing communications channels, the authentication expires if no new sessions are created through the firewall from the host device within the configured timeout value. Choose the type of timeout that best suits the authentication needs of your environment. Good job! You now understand authenticating through captive portals. Next, you'll learn about monitoring and troubleshooting. After completing this section, you should be able to monitor firewall users, use troubleshooting tools, use best practices. By demonstrating competence in monitoring and troubleshooting, you will be able to monitor authenticated users and troubleshoot any issues that may occur. You can monitor users who authenticate through your firewall policies using the Firewall User Monitor page. It displays the user, user group, duration, IP address, traffic volume, and authentication method. It does not include administrators because they are not authenticating through firewall policies that allow traffic. They are logging directly into the FortiGate. This page allows you to disconnect a user or multiple users simultaneously. In the Web-Based Manager, a good tool for troubleshooting is the Bytes column on the Security Policy page, which is opened by clicking Policy and Objects, IPv4 Policy. This column displays the number of bytes that have passed through this policy. This is valuable information to have when you're troubleshooting. When you are testing your configuration, end-to-end connectivity, user authentication, policy use, watching the byte count for an increase can help with troubleshooting. An increase indicates if the policy in question is seeing any traffic, which is useful if you expect a user to require authentication but they are never prompted. Use the following CLI commands to gather more information about users and user authentication attempts to help troubleshoot failed authentication attempts. Diagnose Firewall Auth List shows authenticated users and their IP address. Diagnose Firewall Auth Clear clears all authorized users from the current list. This is useful when you need to force users to re-authenticate after system or group changes. However, this command can easily result in many users having to re-authenticate, so use it carefully. Diagnose Debug App FNBAMD-1 used to troubleshoot active authentication must use in conjunction with Diagnose Debug Enable. Diagnose Test auth server radius-direct, IP, port, secret. Tests pre-shared key between FortiGate and the Radius server. Use the best practices listed on this slide to avoid unnecessary issues when configuring firewall authentication. Congratulations, you have completed the lesson. Now you will review the objectives that you covered in this lesson. This lesson covered the following objectives: describe firewall authentication, identify the different methods of firewall authentication available on FortiGate devices, identify supported remote authentication servers, describe active and passive authentication and order of operations, configure users for local password authentication, server-based password authentication, and two-factor authentication. Configure remote authentication servers. Configure user authentication. Understand the roles of LDAP and Radius. Configure user groups. Configure firewall policies. Configure captive portal and disclaimers. Monitor firewall users. Use troubleshooting tools. Use best practices.